The last thing we need to talk about is a net ionic reaction. Sometimes it's important for us to see the details of aqueous reactions involving the ions in solution. You're very comfortable, hopefully by now, with the molecular equation. It's that typical equation where you keep all the molecules together. What I'm about to show you is how you can separate the molecules that are in aqueous solution apart into ions, and then modify that equation, canceling out spectator ions to give you a net ionic equation, which it would be a final equation that shows all the major players in the reaction. One of the things that you'll need to remember to do in the complete ionic equation is separate any substance that is aqueous into the positive and the negative ion, the cation and the anion. Anything solid will stay intact, and we need to be aware of any coefficients in front of the chemical formula. Coefficients will always multiply by the subscripts, which will then tell us how many ions each one of the substances is splitting apart into. So let's take a look at our first example. The molecular equation here is potassium iodine reacting with silver nitrate to produce silver iodide, which is your precipitate, and potassium nitrate. In order to do a complete ionic, we're going to separate out anything that is aqueous into ions. And so you can see that the K and the I have separated to K plus and I minus. The silver nitrate has separated into Ag plus and NO3 minus. The AgI is staying together because it will not split apart into ions. It is the precipitate. And then the KNO3 was determined to be aqueous as well, so that's going to split apart into K plus 1 and NO3 minus 1. Now what we're going to do is we're going to look for any ion that is the same on the reactant and the product side. So we can see that the potassium ion is identical on both sides, as well as the nitrate ion. Those are called spectator ions. They do not participate in the reaction, and so we need to remove them. Once we remove them, what is left is the net ionic equation, referencing the major players of the game. And in this reaction, the major players are the silver ion and the iodide ion, which are coming together to make the precipitate silver iodide. Let's try another example. This time, you'll notice that there are some coefficients, and those are going to be important for us to look at. If you don't see a coefficient, we assume it to be 1. So the first thing I'm going to notice is that the sodium hydroxide is aqueous. That's going to split apart into the sodium ion and the hydroxide ion. There is a 2 as a coefficient, so that gets multiplied by each subscript. And so sodium has a subscript of 1, so that would be 2. And so does hydroxide, so that's also going to be 2. Copper chloride is also aqueous. We're putting a little plus here for this guy right here. And we're going to break that apart into the copper ion, which is a +2 ion, and the chloride ion, which is a -1 ion. Now we're going to put a plus between those because we're separating them out into ions. You'll also notice that there are 2 chlorine ions here, so I do have to put a 2 in front of that. The coefficient was 1, so I don't need to do any special multiplication there. I'm going to put my arrow here, and once again I'm going to break this down into the sodium ion, which is a +1 ion, and the chloride ion. There is a 2 in front of it, so that means I have 2 sodium and 2 chloride. And then my copper hydroxide is my precipitate, so I'm going to keep that intact. Now I'm going to look for anything that is the same, and so that would be my 2 sodium ions. I also have 2 chloride ions. And what that leaves me behind is the copper 2 ion, 2 hydroxides, and on the product side, what is left behind is copper hydroxide. And that is your net ionic equation. Let me remind you that one of the quickest ways to come up with the charges is to work backwards. If you are looking at a chemical formula and you see subscripts, a lot of times, this works most of the time, you can bring those numbers back up and those will reference the ion's charge. If you don't see a subscript, we know that those charges were equal to each other, and you just need to go to the periodic table and identify one of them, and that will help you then identify the other. This last one I would like for you to try on your own. When you think you have the right answer, go ahead and turn the vodcast back on. Alright, so in this case right here, I've got iron chloride. I'm going to break that down into Fe. See that it's +3. And the chloride ion is -1. There are 3 of them, so I'm going to put a 3 in front, and the coefficient is 1, so I don't need to do anything with that. Sodium hydroxide is going to split apart into the sodium ion and the hydroxide ion. There is a coefficient in front, so I do need to put that in front of each of these. We're going to do the arrow. This time you see the iron hydroxide as a solid, so we're going to leave it intact. And then I've got my sodium ion and my chloride ion. And there's a 3 sitting in front, so that means I have 3 each of those ions. I'm now ready to get rid of any identical ions. That would be my sodium ion and my chloride ions. And what that will leave behind is the net ionic. The iron 3 ion is reacting with 3 hydroxide ions to produce iron